Good afternoon and welcome back. In our last section, we were talking about the automation of routine work, and we were answering the question about why we should use database management systems at all. In the next section, we're going to look at the evolution of database technology and the gradual movement towards accessing big data and cloud computing. So let's give a very brief overview. So I'm going to take these 2-3 pages and I'm going to shrink it down. And I'm going to show you that in the first generation of databases, they were very complicated in that accessing a database required writing actual computer code, required writing programming code. And the program itself was not necessarily viewed as separate from the database. Okay, searching was also much more difficult. It was either sequential or random. Now, in the second generation, they moved towards introducing and using entities and then connecting them across tables with relationships, as we talked about. SQL was introduced. There was a standardized language to access the database, but you still had to write basic code for the most part to access these databases. By the third generation, they were using non-procedural language, and they were routinely processing through these pieces of automated work. There was transaction processing. By the fourth generation, this is largely what we are doing today as we're using big data or we're processing large amounts of data to support decision making. There's distributed processing across multiple databases or even data centers. And we've begun integrating database management systems with cloud computing, or in that users can access it from a distance. Okay, so that brings us to the actual design and architecture of database management systems themselves. We should ask the question, as we move towards these more complex database management systems, how are they actually designed? What is the architecture of these database management systems? Okay, well, as we just talked about previously in the first generation, in order to access the database, you had to write code. The program was not seen as being separate from the database. So in order to access the database, you had to write programming code. Okay, and each program had its own code. So to change, if you were to change the database, you would have to change the code within every program. And this is terribly expensive. In fact, the textbook says maybe half of all software costs or software maintenance costs went towards updating code when they wanted to update the database management system or the database itself. So that was very expensive and time consuming. So we moved towards what's called database independence. Now, data independence is the idea that the database is separate from the programs and the applications that access it. Hence, we don't need to change every program or every application in order to use the database differently. Rather, we can change the database itself, and they don't affect all the programs that the database will be used with. Okay, we can just change the database itself or change the data on the database itself. So this brings us to the idea of the three schema architecture, or the layers in which a database is described and how we interact with it. Okay, so here's a picture on the right. This is called schema mapping. Here, I'll turn the page so I'm on the right page with you. And so you can see a representation of what I'm talking about here on the right side. In section 1.4, we're talking about the three schema architecture. We're going to call this TSA. And so let's begin by defining the word schema. When we say schema, what we really mean is a description of the database. So a three schema architecture really means three descriptions of a database, or more specifically, three levels of descriptions of a database. Okay, so we see on the right here, we might see one level here, a second level here, and a third here. The external level, or the external user level, the conceptual level, and the internal level. So let's talk about these. So here at the external level, each user sees the database differently. They might describe it differently because their access, these groups of users, they have different levels of access. They see different parts of the database. Okay, they interact with it differently. Now, at the conceptual level, what we're talking about is the actual entities and relationships within the database itself, but across the entire database. And at the internal schema, what we mean here, at this level, we're describing the actual data that is stored onto the database, so files or collections of data. Okay, so you might think of the internal level as the storage of the conceptual level. Okay, if we were to think about this more closely, we might see levels 2 and levels 3 as representations of an entire database. Okay, so in this section, we talked about the evolution of database technology and the move towards big data and cloud computing. And then we talked about data independence, how it used to be quite expensive to modify a database, but now with the 3-schema architecture and with data independence, we see a database as separate from the programs and applications that use it, and we can change, modify, update, or even experiment with the database without affecting anything else. In this way, database administrators can work independently with a database, or they can even experiment with another database without affecting other people's work, or or the data that other people access. In section 1.4, we'll talk about parallel and distributed processing of data. See you there.